We looked at the rules then that outline converting hex to decimal, and we said that we can either convert from hex to binary and then to decimal, or we can convert directly from hex to decimal by summing all of the weighted digits. So let's take a look at some examples. We have the hex number 6B2, base 16, and we want to look at converting that to a decimal equivalent. And we can see that using the rule where we take the values of hex and convert them to the values in binary, we can chunk it up and get our weighted values very quickly to determine the decimal value. So 6B2 then becomes the first binary set of digits, the first bits, 4 bits, 0, 4, 0, 1, 1, 0, and then 1, 0, 1, 1, and then finally 0, 0, 1, 0, most significant to least significant. Well, if we take a look at those, we can see that using the weighted equivalents for each of those, that we have, discarding the first 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0. If we look at the binary weighted equivalents, we have 1, 10, 24, we have 1, 5, 12, we have 1 unit of, no units of 256, we have 1 unit of 128, no units of 64, 1 unit of 32, 1 unit of 16, no units of 4, 8, and 2, 4, 8 and 4, 1 unit of 2, and no units of 1. So in the case where we have a 1 showing in the binary, we just select those values, those factors of 2, 1024 plus 512 plus 128 plus 32 plus 16 plus 2, and we have our decimal equivalent when we add them together of 1,714. So we did an intermediate step there where we could look at the binary equivalent to the hex and then convert that to the decimal equivalent. Okay, in another case here, just a little longer number, but it gives us the same type of result. We have the hex value 9F2D. Convert each of the hex values to a binary 4-bit value, and then determine where we have ones and where we have zeros to determine if the weighted values will be added together. Well, in this case, we have 1 unit of 32,768. We have no units of 16,384 or 8192. We have 1 unit each of 4096, 2048, 1024, 512, and 256. No units of 128 or 64. 1 unit of 32. No units of 16. A unit each of 8 and 4. No units of 2, and 1 unit of 1. So again, we can see we take each of those values where we had a 1, add each of them together, as you can see on the vertical on the bottom, and we come up with our value of 9F2D as 40,749 in decimal. So next we'll take a look at the counting in bases 10, 2, and 16. And just a little recap here, in each of the bases, when 1 or more is added to the highest digit, that digit then becomes 0, and a 1 is carried to the next highest digit position. In tens, we do that every day when we do our additions. So in decimal, 9 plus 1 gives us 0, and we know that there's a carry in the next highest position. In binary, 1 plus 1 gives us a 0, and we have a carry in the next highest position. And then finally in hex, F plus 1 gives us a 0 because we've maxed out the hex value, and we have a carry to the next highest position. So we'll look at that next.